Honors Algebra 2, Chapter 14, Section 2. We're going to be looking at graphing sine, cosine, and tangent waves with some shifting. So we're dealing with our translations of those functions. And so we talked yesterday about if we had a sine bx. So our a value is still our amplitude, and our b is still our, helps us find our period. It's our horizontal shrink or stretch. But now we're going to deal with this h and k value, which we've talked about before. And this is just a horizontal and vertical shift of the function. The thing that becomes confusing with these graphs is that b value, and is it then multiplied through or the quantity, or is it factored out? And that's a big difference. This is the first time you dealt with a function that has a horizontal stretch or shrink, really. And so in this example here, 2 sine 4x plus 3, we have to first figure out what's happening in this problem. There is no h value here, so there's no horizontal shift left or right. There is this 3 value, which is actually a k value. So be very careful about order operations. If you look at order operations, there's really like a parenthesis around the sine 4x. So you put that as a group, then you'll see how this plus 3 is really the k value. So the 3 value will move it up 3. So we're going to go up 3. Our amplitude is still 2. And then our period is going to be 2 pi over b, which is 4. So we have pi halves. So our starting value, we're looking at all these functions and trying to figure out where we start. Our starting value, meaning our x value, is still going to be 0 or 0 degrees or radians. And then our period is pi halves, which is going to be the end of the first period. And so I know I'm going to start here at 0, and then pi halves. So if I call this pi halves, and you choose your scale for your x-axis, I then split it into each period into quartiles. So there's the quartiles for the first period. Now this has been shifted up 3. So if I go 1, 2, 3, this is really like the new x-axis. So instead of graphing this on the original x-axis, we're going to graph it up here on the shifted one. So that's like the original origin, and this will be the end of our period, and I split it into 4 quartiles again. So then if we graph this function, sine starts at our intercept. And when I say intercept, it's really of the shifted axis, not the actual x-axis. Sine will then go to a maximum. Our amplitude is 2, so we're going to go up 2. We're going to be at 5 at that first quartile. At that midpoint of our period, we're back to an intercept. The next quartile, we're down to a minimum, which will be at 1. And then we're back up to an intercept. So this would be the shape of that wave. And that repeats, so we can keep going with that shape. So we should have arrows showing how that period will keep repeating. So it's the same thing we did yesterday. Now we're just going to be shifting it up here. And we could also be shifting it left or right with some functions like this. So now this one here, we do not have a k value. This one. We have the h value here that shifts it right 3 pi. Now, the question is this 2. Okay, this 2 is still our b value. What's it doing in the graph? Now, these would be the same equation as 5 cosine of 2x minus 6 pi. Those are the same thing. So you need to factor that 2 out to see the actual h value. So we're going to shift it to right 3 pi. We have an amplitude of 5, and our period is 2 pi over b, which is 2 pi over 2, or pi. So if I have this be pi, then we actually need to move the graph right 3 pi. So this would be 2 pi, 3 pi, 4 pi, it keeps going. And so the first period on the graph is actually at 3 pi. Our start is the shift right. It's going to be at 3 pi. So that's where we're going to start. We've not been moved up or down at all. There's no k value. So we don't need to move the x-axis up or down. We're going to start here. This is kind of like a new y-axis if you need to draw like a imaginary line here, dotted line, so you see what the new y-axis is kind of like. And so then our period is pi, so this would be pi away. I'm going to split that into quartiles again. I'll find that midpoint and then I'll find the quarters. And from here, I'm going to start at an intercept for our sine. And then we're going to go to the first quartile, go up to a maximum. I go by twos. 2, 4, 6. So our amplitude is 5, so we go up to 5. It's back here. Back to an intercept, down to a minimum of -5, and back to an intercept. And then we're going to make sure that that period is showing how it continues or repeats. So a rough sketch of that period for this cosine wave. And so that would be like the original first period, just been shifted. So for this one we have a Ferris wheel. We know it turns, the Ferris wheel turns for 180 seconds. Your height in feet above the ground at any time t in seconds can be modeled by this equation. So here, t is the time in seconds, h is the height in feet, and then we know we're going for 180 seconds. So graph your height above the ground as a function of time. It's asking us to graph this function. And so if you look at this, we have an amplitude of 85. We have a shift up, we're going to move it up 90. We're going to move it right 10. And then we have a period. That's 2 pi divided by pi 20ths, the same as multiplying by the reciprocal, 20 pi. And so then we're actually, the pi's reduce out, so our period is 40. It keeps going. So we're going to move it right 10. So think about how the y-axis is going to be moved here. We're also going to move it up 90. Our y-axis is going by 30, so 90 is going to be here. So that's kind of like a new picture for the x and y-axis. And now we can know that the sine starts at our origin, which is where these two would intersect. The period is 40, so it's 10, so that would be 50. That's where the period ends for one cycle. And we'll split that into quartiles. So we have 20, 30, 40, 50, so it's split into tens, which is our quartiles. And so we have an amplitude of 85. We're going by 30s here. So I'm at 90. So I'm going to go up another 30. So that's going to be 120, 150, 180. So if I go up 85, that's 175. So it's going to be about here. Back to an intercept, down to a minimum. So it's going to be down to 5. And back to an intercept. So this is going to be one wave, one period. This is showing how on a Ferris wheel you hop on, you're going to go up and then back down and then back up. And so the height off this ground, you think about why does this never hit the x-axis, is because when you get into a Ferris wheel, it's off the ground a little bit. And then you think about how its maximum has Ferris wheel at the top of the Ferris wheels up here. And so that would be the amplitude that we're kind of getting at in the second part of the question. How we have a maximum and a minimum here. So our minimum, that's just going to be 5 feet. Our maximum is going to be that shift plus the amplitude. So we get that as 175 feet. And so here is another way we can do the reflections. When that A value, the amplitude, is negative, it reflects the graph. So negative sine x, instead of starting at the intercept and going upward, we're going to start the intercept and go downward, go to the minimum first. It's a vertical reflection. Same thing we've been doing on the functions. In cosine, instead of starting at a maximum, we start at a minimum, and then we're going to go up after that. So that's what the negative A value does. It's still that reflection. So this is another problem we can look at over time and move on, but it has a negative value, so that sine, it's not been shifted up or down. It's going to have here, and so start going down first, rather than usually how we start going up first side. So let's deal with this one with tangent. We can look how tangent has been moved up 5. We do not have a horizontal movement. Our period for tangent is pi over b. Our b is 1. This will be pi. Our a value is equal to 3. And then we also have a reflection, a vertical reflection because of the negative a value. So we're starting our origin here. Our period is going to go half the period to the right. I do pi halves to the right. And then I go negative pi halves to the left. This is where our asymptote is going to be for tangent. And so the distance between these two asymptotes is going to be our period pi. Our quartiles are negative pi force and pi force. Shift it graph up 5, so I should move it up 5. Let's go 2s, 2, 4, 6. So up 5, so this will be like a new x-axis here. And so this would be where we're really starting at the origin. So because of reflection, we're going to use our a value into this quartile. Instead of going up like we did yesterday, we'll go down because of reflection, down our a value 3. So we're at 5, so we went down 3, we're going to go 2. If I go the other direction, we go up. You think about our cubic kind of shape, it has that negative shape or negative decreasing rate of change. Same thing's true with this function. So this would be the shape of that tangent, a rough sketch of that tangent rate. So applying some of this knowledge here to write an equation. We can write the equation where y equals negative 2 times tangent 5x, translated down 4 units and left pi. So it's the same equation, same a value. Tangent 5 times the quantity of x. We're going to left pi units, going to be plus pi. And I'm shifting it down 4, so it's minus 4. The next one, we're going to translate the unit up 4 units and reflect over the x-axis. That's y equals negative 1/4 cosine. And then we're going to go 2 units or 4 units up, so we're not changing that. We don't have the h value, but we're going to add a k value, add 4. And the last one here, we're going to go right 3. We're going to reflect it. Over the y equals negative 2 line. So a horizontal reflection. That's just saying really we have a negative a value. That's the vertical reflection. The right 3, so we do x minus 3, or shift to graph right 3. So that would be the equation. Call that good for the night. So that would be graphing like yesterday, but we're dealing with our horizontal and vertical. And one thing I do want to remind you is that with all the ones we've done here, this b value has been factored out of our quantity. We need to realize that sometimes problems can be written as this. And if I had a problem like this 5 pi, that is not our shift left or right, because the 5 has been multiplied through. We need to factor that 5 out to actually see the h value. So be careful about that quantity and if that b value is multiplied through. So we'll see you tomorrow.